All right, folks, we're going to jump in with some practice problems for velocity. First up, we have calculate the displacement of a person who walks with an average velocity of 7 meters per second for 4 minutes. Just a note before we start, I didn't talk about this in the last video, but when we have something that is a vector, if the number doesn't have a sign, we assume it's a positive number, and that positive implies the direction. We would need to see a negative sign for it to be the other direction. So we assume positive direction unless we see the negative sign. So this is a velocity of positive 7 meters per second for 4 minutes. Average velocity is displacement divided by time. And so one thing that I recommend whenever possible is to rearrange an equation before you solve it. We're solving for displacement, and so displacement is going to be the average velocity times the time. Okay, and so this looks to be pretty straightforward. The only problem is I have 7 meters per second for my velocity, and I have 4 minutes for my time. So you're going to want to make sure that you read carefully for units, and the units have to match. Because the velocity is in meters per second, we would need to either convert the velocity to meters per minute or convert the time to seconds. I'm going to just convert the time to seconds. In 4 minutes, that's 4 times 60. That's 240 seconds. So you can convert things with dimensional analysis or however you know to do that. So we would take 7 meters per second and multiply by 240. And that would give us 1,680 meters. Sig figs is not a big thing in AP Physics 1. Which is why you can see I have two numbers that have 1 sig fig. We'll talk about sig figs more when we do labs, but for right now, just focus on like the routine of doing the problems. Next up, we have a cart begins at x naught equals positive 60 centimeters and rolls to x equals negative 50 centimeters in 2.9 seconds. Calculate the average velocity of the cart. So average velocity is again displacement over time elapsed. Okay. This time we have like the two initial and final positions, and they're also in centimeters. So I'm just going to make a note that 60 centimeters is 0.60 meters, and then negative 50 centimeters is negative 0.5 centimeters. So I'm going to have to keep track of that. Okay, this is set up to solve for average velocity, so I'm just going to go ahead and plug things in. Displacement is final minus initial position, so I'm going to start with negative 0.50 meters. Messed that up right there. Minus, so that's the final position, minus the initial position, which is a positive 0.60 meters, all divided by 2.9 seconds. You can calculate things one piece at a time if you want to, or you can do it all at once. I'm going to do it all at once. Negative 0.5, actually I'm going to do it in 2 steps. Negative 0.5 minus 0.6 is negative 1.1 meters divided by 2.9 seconds. So when I calculate, I get negative 0.38 meters per second. And so this object was moving in the negative direction, and so the average velocity is negative. All right, and then we get to a slightly more complicated question. So a cat saunters from the couch to her food bowl, taking 22 seconds to get there. As soon as she arrives, a loud noise scares her, and she bolts back to the couch in 2.5 seconds. If the food bowl is 3.3 meters from the couch, calculate her average speed and her average velocity. So let's do part A first. Average speed. So this is going to be V equals D over T. Okay. Now we have to consider everything that happens with the cat. This 22 seconds is the first part of the journey where the cat goes from the couch to the food bowl. And then the 2.5 seconds is when the cat is like sprinting basically back to the couch from the food bowl. So those two times will combine to form our total time elapsed. So I'm going to do the denominator first. So 22 seconds plus 2.5 seconds. That's going to be our total time. Okay. The last piece of data is that there's 3.3 meters between the food bowl and the couch. And now we still have to keep in mind, right? The cat goes from the couch to the bowl, and then from the bowl back to the couch. So she does this like 3.3 meter trip twice. And just to kind of like group everything together, I'm going to add it to itself. And what this is showing me is the cat goes 3.3 meters in 22 seconds, and then also goes 3.3 meters in 2.5 seconds. So both legs of the journey are represented in separate parts of that fraction. 3.3 twice is 6.6 meters. And then 22 plus 2.5 is 24.5 seconds. So 6.6 divided by 24.5. And this average speed is 0.27 meters per second. Okay. Speed is a scalar quantity, so I don't need any direction there. The cat actually changes direction, and so it's just the magnitude is the speed. All right. Part B. Part B is average velocity. So average velocity is displacement divided by time. Okay, so I'm going to set this up, but if you've been like following along, you might see the trick here. The displacement I'm going to do in a minute, but the time is the same. So 22 seconds and 2.5 seconds. That's the total time elapsed. Now displacement is final position minus initial position. So maybe you can make a map in your head, or maybe you actually want to write this down. But if we like map out the bowl and the couch, I don't know why I did that in this order. The cat does two things. The cat, actually, I'll do this. The bowl is going to go there. The bowl is going to go over here, just because we're like most often left to right thinkers. The cat goes from the couch to the bowl, and then from the bowl to the couch. Now, if we make this 0 meters, and this location for the bowl 3.3 meters, we can pretty clearly see that the cat begins at a position of 0 meters and ends at a position of 0 meters. In other words, because the cat begins and ends this event at the same location, the cat's average velocity is 0 meters per second. Right. So hopefully that's enough to get you started on some velocity calculations. Good luck.